Hello, everybody. Welcome back. Today we have our next lesson. We're moving on to 8.3. First, glad to see a lot of you got some emails saying that second video helped clear some things up. Okay, I'm glad. That's why I say always reach out to me if you need help, because then it helps me adjust the class. Okay, I think for a lot of you, we really needed that review video Monday, so I'm glad that helped out. Today, we are moving on to what I will admit is personally my least favorite part of all math I've ever learned ever. However, doesn't mean it's hard, just means, nah, I'm not a big fan of it. I don't like trigonometry, but you're gonna need it if you move on from geometry. So today we're talking about trig, which is sine, cosine, and tangents, where we're gonna start. One thing to remember, when we talk about this, whenever you're working with trigonometry, whenever you hear that word, you're studying triangles, okay? When we talk about sine, cosine, and tangent, the one thing you need to remember, we are working with right triangles, okay? Right triangles. So that's the given. That's the thing you have to have. You have to have a right triangle. So here's what it is. I have it written down here. Here's your new favorite phrase, SOHCAHTOA, okay? SOHCAHTOA, SOHCAHTOA, okay? If you can remember that, it helps tell you kind of what each of these is. So for example, the first part, so the sine of, and if we're using this picture, the sine of A, because when we talk about this, we're talking about the angle, so we're saying the sine of angle A. The sine of angle A equals the opposite over the hypotenuse. What that means in this picture is the sine of A equals the opposite, so what's directly across from it, so that's A, over hypotenuse. Hypotenuse never changes, it's across from the right angle. So then in this case, that would be our side C, okay? Now, of course, all of these are going to be numbers, the lowercase ones. Usually when we're solving for an angle, we'll leave it as the variable, but these will be numbers and you'll be trying to find a certain value, okay? Similarly, cosine is adjacent over hypotenuse. Now, adjacent just means next to. It's the side directly next to that angle, okay? So in this case, if I did cosine of A, whoops, I need to put the A in there. All right, it's there. If I did the cosine of A, what I'd be doing is the adjacent. So I'd look at angle A and I'd say, what side is next to angle A, okay? Now, here's the trick. There's two sides, right? Well, it can't be the hypotenuse, because if it was the hypotenuse, we'd call it the hypotenuse. So we know it has to be B over hypotenuse, which is C, okay? And then finally, tangent is opposite over adjacent. So if I did the tangent of A, I'd be looking at opposite, which is A, over adjacent, which is B. Okay? I apologize. I don't know if you guys can always hear my dogs wrestling or fighting, whatever they're doing, but for some reason they never do it throughout the day unless I'm videoing a lesson. So I apologize you always get to hear that. Okay? So that's SOHCAHTOA. That's your base for trigonometry. Okay? So let's look at a couple examples. I'm going to pause it, put some examples on the board, and then we'll go through them. I'll show you kind of what you're going to see on your homework. All right, so here we go. We got these problems up on the board. Looking at the first one, okay? This is the basic one. This is me. If I give this to you on a quiz, what I'm seeing is, like, do you just know the basics? Do you know SOHCAHTOA? Do you know that order? Do you know what is related to what? So here, they just want to say, find the sine, cosine, and tangent of, in this case, I said B, okay? So this one, not a lot of math involved. It's more so just putting things in the right place. So I'd come here and I'd say, okay, the sine of B. So I'm looking at this angle. Sine is opposite over hypotenuse. So I'd go opposite, which is 7, over hypotenuse, which is 15. Now, if that's reducible, I need to reduce it. In this case, I can't, so I just leave it as is. It's 7 over 15. That's perfectly fine, okay? So now I'd go on to cosine. Cosine of B equals adjacent over hypotenuse. So I look at B and I say, what's next to B? Well, 15 and 3 are next to B, but 15 is the hypotenuse, so I wouldn't be talking about that. So it's adjacent over hypotenuse. 3 over 15. And then I say, oh, can I reduce it? Yeah, I can. I can take a 3 out of both. So it's really 1/5. Okay? Then finally, tangent of B equals opposite over adjacent. So I go opposite 7 over adjacent 3. So it's 7/3. Okay? 7/3. Quick hint for you. Because the hypotenuse is the longest side, we know that always has to be true. If you ever get anything bigger than 1, okay, for cosine and sine, if you ever get anything that's like 3 over 2, okay, you right there, it should be a red flag saying, hey, I messed something up, because those should not be bigger than 1, okay, unless someone gives you a triangle that isn't technically correct because they put the hypotenuse at the wrong size, okay? So make sure you're aware of that. Okay, now 2, 3, and 4, this is what you're really going to be looking at. These are the tougher ones. This is where you're trying to find something. Okay, so in number 2, we're looking for x. Okay, and they gave us an angle measure. Okay, so here's what you got to do is you got to say, okay, looks like I have 3 pieces, 2 sides and an angle in a right triangle. Looks like it'd be perfect for a trig function. So first thing I need to do is identify which trig function I have the pieces to. So I have to think, all right, I'm obviously going to use the angle that I have. From that angle, what sides do I have? Well, I have the side across from it, so I have opposite, and I have the side next to it that's not the hypotenuse, so I have adjacent. So I need to think and go, okay, which one of these have opposite and adjacent in it? Well, tangent has opposite and adjacent, so I need to set up an equation for tangent. I need to say the tangent of, and this will always be your angle, equals opposite over adjacent. Okay? Now, I just need to solve this. Okay? And here's the deal. It's really not too tricky. I lost my phone, which is my calculator. Okay? On your guys' calculators, you will notice that you have buttons that say sine, cosine, and tangent. Okay? So, here's the thing. This right here doesn't have any variables in it. That's just a number. So I can go to my calculator and I can put in, let's see if my phone has it. Should. There we go. I can do 35 and then click the tangent button and it gives me that value. Okay? So what I have here is 0.700208 rounded. Okay? So now, I gave you actually the hardest one, the hardest type of problem like this. When you have the variable on the bottom, that's going to require the most steps, okay? Because if it wasn't on the bottom, then all you'd have to do is multiply by whatever number's in the denominator. However, here, we have to multiply by x to get it out of the denominator. On this side, it cancels. Multiply by x, okay? Which now leaves me with x times junk, I'm just going to leave that as junk for now, equals 4. I'm just being lazy. I didn't want to write it. Okay? So now, last step, all I need to do, divide by that 0.700208, divide by 0.700208. Okay? Now, what I would recommend is I rounded for my work. Okay? When I go to plug this in at the end, though, I want to be as accurate as possible. Okay? So I would put into my calculator 4 divided by 35, or whoa, sorry, that was wrong. 35 tangent, just kidding, that was good. And actually plug that in again. Okay, so on my calculator, I'm not using the rounded number. So I literally typed in 4 divided by 35 tangent. Okay? That way I'm dividing by the actual number and there's no rounding error. Okay? What you end up with, and now you can definitely round your answer, is that that side is going to be 5.713 when rounded. Okay? Trig has a lot of rounding involved if you're actually looking for a number. I'm going to be real honest with you. There's not a lot of clean things going on. And for right now, I'm going to be all right with you using decimals. Now, when you move on to trig and calculus and all that, you're going to deal with the same type of stuff where everything is fractions, and you deal with a radian circle and all that good stuff. But I'm getting ahead of myself. That's just a preview of what's to come in your near future. Okay, so my answer is x is 5.713. Makes sense because if this is 90 and that's 35, that makes this 50. Let's see, 55, which means this side has to be bigger than this side because it's across from the larger angle. So I know at least by that rule, I'm probably good. Okay, so that's how you set that up. Okay, second one here. Now we're given an angle. Okay, again, so it looks like same type of problem. So I need to determine, what do I have? What do I have? I have the angle, or the side next to it, adjacent, and I have the hypotenuse. Okay, and I have the hypotenuse. So I'm going to say, okay, adjacent hypotenuse, that looks like a cosine to me. So I'm going to do cosine of 40 equals adjacent over x. Excuse me. Adjacent over hypotenuse. Which again, I'm trying to show you the harder one, so again, the variables in the denominator takes more steps. Okay? Now, here's one thing you can do to clean up your work. So, I showed it all the way out, kind of show you how things work. Now, here's how I do it. Here's how you keep things a little cleaner. You look here and you say, okay, cosine of 40 is going to be a gross number, and I'm not quite ready for that number yet, so I'm just going to leave it as cosine of 40 and do all my other work. So, I'm going to get x by itself times x, so I get x cosine of 40 equals 10. Divide by cosine of 40. Divide by cosine of 40. X equals 10 over the cosine of 40. And this way I've avoided writing out a really long decimal and junking up my work till now I'm ready to put it in a calculator and go 10 divided by 40 cosine. So what I get is 13.05. Okay, and again, it all depends on what I'm asking you to round to. The first one I went to the thousandth, this one I went to the hundredth. Just make sure you're paying attention to directions. Okay, that's how you keep your work from getting junked up. Leave it all together until you're ready for it. Now, of course, when the denominator, or when the variable is not in the denominator, it does become a lot easier because you only have to do the one multiplication across. Okay. Finally, here's where things get a little rough. Okay, if I said I wanted you to find angle A, I shouldn't say rough because I actually think this one's not, I don't think this one's as bad. Okay, so what I do is I still look the same way. I say I have an angle. I have angle A. I have opposite and hypotenuse. Opposite, hypotenuse. Ooh, looks like I'm working with a sine. A sine. So I have sine of, unfortunately this time, I don't have the actual angle, so I just have to put sine of x. Okay? Equals opposite over hypotenuse. Now, one thing I probably want to do right now, make things easier for myself, I should simplify that fraction just to make things a little bit simpler. So divide out 2 out of both of those, I get 3/5. So sine of x equals 3/5. Okay? So obviously the problem here is the variable is inside of the sine. Ooh, that's a little different then. Okay? Here's the thing. There are inverses to each of these functions that work like saying 5x and then you divide by 5 to get x alone. If I have sine of x, I do the inverse of sine to get x alone. Okay? So what I do is I do the inverse sine, which is just the name with a -1 above it. Okay? The inverse sine to both sides. Okay, so here I would do the inverse sine. So what I end up with is x equals the inverse sine of 3/5. Okay? And that's how I cancel it out. Because now I have a trig function with something inside of it. And on your calculator, you'll notice for most of you, if you're using like a TI-83, it's going to be, you're going to have to click the second button, and then usually it's just the sign button. So right above it, written in whatever color, yellow, it'll do the sign -1. Okay, so now all we have to do is say, okay, I take 3/5, 0.6, and then take the inverse sign of that, which on my phone looks funky. I think I have the right thing, maybe. Ooh, I don't have it. All right, so I don't have the inverse sign on here. So give me a second. All right, so got it. Just a quick reminder, if you're using a TI-83, make sure it's on degrees, not radians for this, because radians will give you a decimal, where obviously if we're looking for a degree, I mean, it could be a decimal, but realistically, we're not going to work with that small of angles. So what came out when I plugged that in was 36.87, okay? And don't be a robot, of course. Know that what you're saying is, oh, that means that that degree is 36.87, and I was able to use trig functions to find it, okay? So that's your intro into trig functions. We'll come back and do some homework on this Friday. I'll probably post a video showing me working through a couple to kind of get ahead of the curve so we don't quite have as much confusion as last time. Also didn't help that I touched something wrong last time. But this is what we got. Let me know if you have any questions. Otherwise, somebody try and beat Easton to first comment again. Sorry, Easton. Just love the challenge. Love seeing people stepping up to it. Otherwise, enjoy your day. I will see you all later. Stay safe, stay healthy, stay busy.